Okay, I want to give you a tiny bit of advice regarding the Monopoly assignment. I don't want to give you too much. I don't want to tell you how to do it, but I'll give you just an idea of what I did, and I think, it probably does not need to be much more complicated than it has to be. So I'll tell you. At the end of the day, I had three functions in the, I don't know, I guess at the global level, and those were take turn, and the chance deck, and the community chess deck. Okay, those were my three functions, and then I added a whole bunch of methods to the player reference class. I didn't have any other reference classes. I just had the player reference class and the tracking reference class. Those are the only two reference classes that I have. Okay, and then as far as the functions go, just take turn, the chance deck, and the community deck. Yeah. Oh, I'm sorry. Yeah, there's the manual dice, which is a reference class, and then the dice function. Okay? But beyond that, in terms of what you need to program, the dice function is there. I mean, if you want to add verbose options to things or not, that's up to you. I want to say, like, for these functions, okay, like your chance function should be, sometimes your chance function, the thing you want to pass to your chance function, you don't want to pass the actual field values of your object. You want to just pass the entire object into it. Okay, so you can pass like the player reference class object to the chance function, and I promise you this will make your life easier. If you pass the object to the function, you don't have to worry about too much, right? Because this player object contains its own methods and stuff like that. So let's say, you're going to say like the card drawn is, you're going to sample, maybe I'm doing too much here, right? Sample 1 through 15. You're just going to draw one card, right, at random from the deck. And then you're going to do something like if the card is the first card, which is advance to go, all you have to do is, because you've passed it the player object, you're going to do player, and you're going to use the method go to space, go to space n and move to space 1, which is, I forget what the actual method is called, but something like this, okay? And this takes care of it. All right? You don't have to make it any more complicated than this, okay? Maybe you want to do a tracking thing here. So you would pass it not just the player, but you would also pass it the tracking thing, and the tracking you would do a tally method in there, okay? Because otherwise, if you don't do it this way, you're going to have to worry about things, about the way functions work, right? So, otherwise it's going to look something like this, right? Your chance function, you're going to have to do, as a function of something, right? And then you do, the card is you sample 1 through 15, 1. And then you'd have to do if card is equal to 1, then, new position. Shoot, I did something. Okay, new position is going to be 1, and then you have to do at the end return new position. Okay, and then the way you have to run this thing is you'd have to do, somehow inside take turn, you'd have to do player $ position is going to be what chance underscore function returns, right? Because chance underscore function would return the new position, and you'd have to update it this way. Okay, this is going to make your life a lot more complicated. Okay, if you just pass it the entire player object which has the methods in it, it's easy. It's really just this, right? If card is 1, then call the method for moving the token. Okay, so this is why we have reference classes with their own methods. You pass the entire object with the methods in it, and you call the method for the thing. Okay, and this, because it's a mutable thing, it's going to update its own position and things like that. Okay, and some of them needs to keep track of where the position is, right? So if and you can do like if player $position is, if it's at spot 8, okay, and the card is whatever, and you're going to move to this place, right? Because sometimes where you end up depends on which position you are located at. You can do that, and you can update it this way, okay? Because the position is stored inside the player object, okay? And you don't have to make the function much more complicated by saying like if you pass it the player's position and all of this other stuff and have to return all of that. Okay, so this is going to be the chance function, and then inside take turn, right? Take turn is a function, and inside take turn you're going to just do something like, right, like if, because take turn is currently a function of player and tracking, right? And you'll probably want to make your chance function a function of player and tracking, and inside here you just do if player position is equal to one of the chance spaces, whatever it is, space 8, okay, then then call chance function on the player. Okay, that's all you have to do, and then it'll run. Okay, you don't have to. Don't make your life harder is what I'm saying. All right, and so just think about what the appropriate methods are. I've given you 2 major methods, which are moving your space and moving and teleporting to another space, right? Move n spaces or move to space n. Those are 2. You're gonna probably want to have a method for going to jail and getting out of jail and stuff like that, and fields to keep track of whether you're in jail or not. And those are the things you want to update with your reference class. But it does not need to be more complicated than it has to be. Okay. And this way it'll run much faster too. Okay, I was timing it. I did like 1,000 games. It took about 5 minutes to run. Okay, it should not take an hour to run 1,000 simulations. Okay. Okay. Are there questions on this? Are we okay? I would recommend getting started sooner than later, so you are aware of what needs to happen and what needs to be fixed. Okay, you'll have all of this weekend to work on it, and I'll have office hours on Monday, and I imagine that will be a busy time with with questions. But I'm happy to answer them. Yes, question.
So after turn 11 on the deterministic dice,
yeah.
is the player trapped in the jail, or it continues?
So I think this should be answered in your Monopoly 20 set turns. So I have the same dice rolls that I gave you guys in that thing. I've set I ran like my super verbose code on these 20 set turns, and you should be able to go through here and see exactly what's happening. So it says, I rolled this. This is where I've moved, and I'm putting a tally here. So you had a question about turn 11, is that right?
3 doubles.
Okay, so after 3 doubles, so I rolled double 4. Okay, I'm at Illinois Avenue. I take a tally at Illinois Avenue. I rolled doubles, so I'm going to take another turn. My double count is now 2. Player is now at North Carolina. We put a tally at North Carolina. We rolled doubles. Okay, double count is now 3, so we go to jail. Okay, so that's at the end of turn. So that counts as 1 turn. That's all under turn 8. Okay, we've rolled the dice 3 times during turn 8, and we end up in jail. So turn 9, we are starting in jail, and we didn't roll doubles, so we stay in jail. Okay, over here, this is going to be my second turn in jail. I've rolled double 4s, I get out of jail. Okay, but I don't go again. Even though I've rolled doubles, I don't go again. Yes?
Is this going to be on CCLE?
This is on CCLE, yeah, yeah. The 20 set turns, it's the same 20 turns you have, and so, you know, part of your assignment is to run these 20 set things on kind of a verbose setting on your thing, and that will allow the grader to kind of make sure your functions are working properly. Obviously, when you do your 1,000 simulations of the game, you're going to turn verbose off there, okay? Because we don't want all of the things. We just want the final table of results there. Yeah.
Can you actually explain verbose again?
So verbose is just, it's a true-false thing, okay? And the way we've implemented it is, so when you're doing coding, okay, if you can just, a lot of times you're just updating values, right? And maybe you want to know what values were updated, okay? So we're just having the option of printing out what happened, okay? And so without having to go into debugging mode to see what the values are, you can just have these informative messages that print out, you know, the value of n at this point is this, right? It's things like the players at 19, we're moving 5, we're now at 24. This is what we're expecting it to do, and the verbose option just prints these out. Verbose false, basically, you're going to just have an if statement right before the print statement or the cat statement, okay?
If verbose true.
If verbose is true, okay, and because it's a logical thing, you don't even have to do verbose equal true. You can just do if verbose, okay, because that's going to be a true or false, right? So if verbose, print this message. If verbose is set to false, it's going to be if verbose, so that's going to be a false, and it's not going to print out those messages, and it's just going to do the updates. So run it like that, and we can see. So here's an example where we landed on space 31. We go to jail, so we put a tally at jail. And then this is my first turn in jail. I rolled a 1-2, I stay in jail. Okay, this is my second turn in jail. I rolled a 3-6, we're staying in jail. Okay, over here, I rolled a 5-4. This is my third turn in jail, so I get out of jail. Okay, and because I rolled a 5-4, I'm at 11. I moved 9 spaces, and I'm now at space 20, New York Avenue. And so I put a tally at New York Avenue, is what it says. Okay, turn 15. And so this text is, I'm hoping, useful in allowing you to check. I guess I'm giving you the answers here, but without showing you the source code. So you can kind of check to make sure your program is behaving the way it should be. Yeah, question?
Yeah, but after turn 8, I think the player doesn't stay in jail at turn 9 and turn 10 as well. It's just like everything happens in turn 8.
So in turn 8, they go to jail, and in turn 9, they stay in jail, right? And in turn 10, this is their second turn in jail, but they rolled doubles, so they got out of jail. Wait, so I'm sorry, what's your question? So this is all one turn. All of this stuff, when you roll doubles and you take another turn, that will still count as the same turn. Okay? So I guess the slight flaw of this assignment is that at some level I was assuming most of you had played Monopoly as part of your life experience, and I'm finding that may not have been a good assumption. I'm curious, you know, maybe I should take a survey of whether students have played Monopoly or not, and I suspect there's going to be some demographic trends about whether we've played Monopoly or not, but anyway, okay. So anyway, this is what happens, okay, and I hope it all makes sense here. Okay, today I wanted to spend time looking at another simulation, okay, and and this is a large part of computational statistics and doing stuff is doing some simulations, and I think the Monopoly assignment is a good example of a semi-complex simulation that is still doable for a homework assignment. Okay, here we'll take a look at a simulation for the game of blackjack. Okay, and this is a much more complicated simulation, but I think there's a lot we can learn from looking at good code on a simulation. Okay, and this chapter is written by Hadley Wickham, and so he's very good at coding, and I think the code he writes he doesn't waste any lines on silliness in code. He's very precise with the code he writes, yet it's very understandable and readable, which are all good signs of good coding. Okay, and this comes from a textbook called Data Science in R, a case studies approach to computational reasoning and problem solving. Okay, that textbook is available to you for free at CRCNetBase. CRCNetBase, and all you have to do is just look up this textbook, Data Science in R. It's part of the title of this thing, and it covers a bunch of really neat examples of some computation, problems in data science and computational statistics. And I think, if you have the time, I would encourage you to kind of look through some of those chapters. But today we'll talk about the game of blackjack. Okay, have you guys played the game of blackjack? Some of you. Who has never played blackjack? Okay, all right. So there's a decent amount of you. All right. And I don't know if you guys are even 21 and if you've been to Vegas and you've played blackjack at a table or not. Well, anyway, so moral of that story is don't go to Vegas expecting to win. All right, you might win, but don't. It's not a sound financial strategy for making money. Okay, you're paying for entertainment, and that's part of that. Okay. So anyway, the game of blackjack, it's fairly simple, but there's some rules that make it complicated. Basically, you get dealt 2 cards. The dealer gets dealt 2 cards. You look at your cards, and you add up their values. Okay? And the goal of blackjack is to get as close to 21 as possible without going over. Okay? And when you get looking at your cards, you always have the option. You can choose to hit or you can stand. Okay? And you can choose, hit means I want another card. Stand means I don't want any more cards. I'm happy with the total I have. Okay? And so you keep asking for more cards until you get a number you like, and then you compare your number versus the dealer's number. And whoever comes closer to 21 without going over is the winner. Okay? If you go over 21, you automatically lose. And this is how the casino maintains its edge, in that you have to make a decision on whether to hit or not before the dealer does anything. So you have to make the choice, and because of the rules of probability, you're at a disadvantage here. Okay? And because if you go over 21 and the dealer happens to go over 21, then you lose, even though the dealer has technically also lost. But anyway, so that's how it goes. And in the deck, here I'll show you. This is I've posted this code. This is code coming directly from the example. The cards are all worth their value, and the face cards are all worth 10. Okay, so you have ace through 10. They're worth 1 through 10, and then jack, queen, and king are all worth 10. Okay, and in the game of blackjack, it's just the value. The suits don't matter, and there's no difference between having a jack or a king or a 10. Those are all worth 10. It doesn't matter what it is or is not. Okay, so if you have an ace 10, that is considered blackjack. That is an automatic win. Okay, it's an automatic win unless the dealer also has an ace 10. Okay, and then you just tie. Okay, But otherwise, if you have a blackjack, ace 10, that's an automatic win. You get 1.5 times your bet. Otherwise, you get 1 time your bet. Okay, so here we can just create a deck just by saying 1 through 10, and then we have a 10 for the jack, 10 for the queen, 10 for the king, and we're going to repeat that vector 4 times, and this is going to form our deck here. Okay, let me just okay, so this is my deck. So here's my deck. Okay, this is these are our 52 cards. I'm going to create a function just to shuffle the deck, which is all it does is it samples, takes a sample, it just shuffles the deck. All right. However, with shuffled decks is it takes the argument n, and so 1 will just do shuffle 1 deck. If I shuffle 2, it'll return a vector of 104, and it's got 2 decks, and they're all shuffled up here. Okay, so this is the function for shuffling the decks. We're going to create a function to calculate how much our hands are worth. Okay, and in blackjack, your hand is just worth the sum of your cards. But there are a couple special rules. If you have an ace, the ace can be worth 1 point or 11 points. Okay, and so that's how the ace 10 is worth 21. Okay, an ace 10 will be worth, in that case, the ace is worth 11, and then you add the 10, you get 21. Okay, so the way we're going to do it is if any of the cards is a 1, meaning it's an ace, we're going to add 10 to the value. But we only want to add 10 to the value if it's not going to cause us to bust, right? So if we add them up and our current, if we have a 5, and an ace, no, I'm sorry, let's say a 6, a 7, and an ace, okay? 6 plus 7 plus 1 would be 14, okay? We don't, in this case, we don't want to have the ace worth 11 because, you know, if it were 6 plus 7 plus 11, I would be now at 24, okay? And that would be a bust. So in that case, we're not going to add 10 to our thing. And if, so we're only going to add 10 if the current value of our cards, if I have a 6 and an ace, that's worth 7, I can add 10 and it'll be worth 17 and I'll be in the clear. So we're only going to add 10 if the sum of our cards is 11 or less, okay? So that's what we have here. If the total of our cards goes over 21, our hand is going to be worth 0. Okay, so the way we're going to check whether we've won or not is we're going to compare our hand value versus the dealer's hand value. Okay, and so if the value, when we add up our things and we go over 21, our hand is going to be worth 0. Okay, but we do want to acknowledge that a blackjack is a special win versus a 21. So if you get 21 points by having 3 cards, okay, like if you get a 5, a 6, and a 10, and you get 21, that will still get beaten by an ace 10. Okay, an ace 10 is a blackjack. That one gets special priority over something worth 21 the old-fashioned way. Okay. So here we want to give special value to blackjack by saying if you have 21 and you only have 2 cards, which is only possible with an ace 10, we're going to give it 21.5. Okay? Otherwise, it's just going to be the sum of your cards. That's what we do here. Okay? So here's a function for hand value. And we can test to check to see if our hand values are worth it. So here's a list of things, and we just want to say, okay, will 10, 1 return blackjack? 10, 5, 6, this will add up to 21. 10, 1, and 1, 10 and 2 aces should add up to 12 and things like that. Okay? And to test this, so this is just part of good coding as you're testing things as you're going along. We can just do sapply. We're going to apply the hand value function to this test cards list. So we're going to do test cards and hand value, that function, and we can just check to see if this is correct. We can create a vector and just say, these are the values we're expecting. Is this in the output of our sapply? Are they identical? And we do get a true there. Okay. So that's to test out if our hand value function is working. We're going to have a winnings function, okay? The winnings function is going to compare your hand versus the dealer's hand and decide if you win or lose, okay? And so in blackjack, if you beat the dealer, you win whatever your bet is, okay? You bet $10, you beat the dealer, you get 10 bucks from the house, okay? If you lose, then you lose that $10, okay? You bet $10, you lose, the house keeps those $10, okay? If you bet $10 and you get blackjack and the dealer didn't tie you, then you get 15 from the house, okay? 1.5 times your bet. And then on the other hand, if you and the dealer tie, it's called a push, nothing happens. You just, the bet that you put down, you keep it. No, you don't take winnings from the house, and the house doesn't take your bet either, okay? And so we're going to take advantage of the fact that R coerces true-false values to ones and zeros, okay? So here we're going to just say if the dealer has over 21, meaning the dealer has blackjack. Remember, this is after we calculate the hand value, we're going to plug two hand values into our function. We got the dealer's hand value versus the player's hand value. If the dealer is over 21, meaning the dealer has blackjack, then you lose unless you tie, okay? So if you have 21 or less, this is going to be 1, and you'll get -1 for your winnings, okay? If you also have greater than 21, then this will be coerced to a 0, and then you'll get 0. So that's going to be your winnings there. If the dealer has dealer busts at 0, then you will get 1.5 times your winning if you have a blackjack, 1 times your bet if you yourself didn't bust, okay? So these will all get coerced to ones and zeros, and then you'll get a -1 if you have also bust, okay? So if you bust, you get a -1. Okay. Otherwise, if the dealer has not bust or doesn't have blackjack, then you win if you get blackjack. You win if you beat the dealer. You lose if the dealer beats you. Okay. So this is the winnings function. Okay. This is another way, a compressed way of running the winnings function, just taking advantage of the true and false that R has. Okay. And here we're going to just test out to see if our winning functions work. Okay, so we're going to test out the values 0, 16, 19, 20, 21, 21.5, and we're going to just see if this works out. So here I'm making a matrix of everything that I expect to win. Okay, this is a manually created matrix saying if I have 0 and the dealer has 0, I expect to lose, right? So if I have 0, then my winnings will be -1 no matter what the dealer gets, okay? If I have a 16, my winnings will be 1 if the dealer busts. It will be 0 if I tie with the dealer, -1 if the dealer gets any of these other values, so on and so forth, okay? So this is just a manual matrix that I created, okay? And here we're going to create an empty matrix called check. Okay, so this just takes the thing and it just puts NAs into everything, and we're going to just run the winnings function for every combination here. We're going to do winnings, and we're going to just try 0 versus 0 and just see if this populates our winnings in the same way that we expect. So here's just a way to test all of this out. So we're going to just run a loop through all of this, and I create check. I look at my check matrix, and it looks like this, and this looks the same. We can also just ask R, are they identical? And R says yes. The check winning, your check matrix and the manual matrix that you created, the test winnings, those two are the same. So we're good there. Okay, so this was just to check to make sure this is working here. Okay. All right, this is where the actual simulation stuff comes in. Now that we've got the hand value function working and the winnings function working, we can run some of the actual simulations. So first we're going to create a function on just drawing cards from a deck. Okay. In the beginning, we'll keep it simple by we're just going to sample the deck. Okay. So the shoe, takes the deck, and it's going to just sample M cards from the deck. Okay, with replacement. So here we're just shuffling this out. So the shoe is a function. So if I just call shoe, it's going to just return however many cards I ask for. Okay, just drawn from the deck at random. And now I'm going to create an object, or here I'm going to I have a function that's going to be new hand, and it's going to return a list. Okay, this is the function takes shoe. We're going to pass it a shoe function. It's going to draw cards using the shoe function, and it's going to keep track of our bet. Okay, and it returns back a list which has the bet, the shoe function, and the cards drawn. So let me just show you what new hand does. So if I do new hand and I give it the shoe, it has default values for the other ones. Okay, so here it's going to return back the bet, $1. It's going to return back the cards I drew, which were 2 6s, and the shoe that I have here is the function. Okay, so the function for drawing cards is included in the new hand object. Okay, much like when you are doing Monopoly, you're going to have the methods as part of the object, and you're going to be passing these entire objects. So it is useful to have the function actually associated with the object itself. Okay, over here it's the exact same thing, except I'm putting the list inside this structure argument, or structure function. Okay, and if you remember the S3 object-oriented stuff, okay, this is how we create S3 objects. And all we're doing is we're just going to give it class hand. So let me just do that. So if I look at new hand, if I call the new hand function and I give it the shoe, okay, it looks exactly the same as before. It draws 2 cards, a 3 and a 10 this time. My bet is 1. The function shoe is still in there, but now it says the attribute for class is that this is a hand object. Okay, and this by giving it a class, I can create its own method for printing. Okay, and so here print method is going to just it's going to say blackjack hand. It's going to paste, print out the cards. It's going to calculate the hand value and also the bet. Okay, so now that I've done print.hand, I can call new hand shoe, and because now it has class hand, this is the way it prints. So I can say, here I want to create a new hand. This time my bet is going to be 7. I'm going to call this my cards, and when I ask for my cards, it's going to print it out this way. This is the way it's being printed. Okay, but if I if I get rid of the hand class on my cards, right? If I ask my cards, it says the class is hand. If I set this to null, okay, and I just ask what my cards is, it's going to print back the old-fashioned way, using giving it back as a list. Okay, so let me just set this back to hand. Whoops. Okay, and then now my cards uses the print method for hand, right? So I don't know if we remember this stuff from the object-oriented lesson. Okay. Okay, and then so now that we are passing entire hands here, we can have functions as functions on these objects themselves. So here I'm going to create a function for hit. Okay, and what hit does is it draws a card and it updates our card. So this is going to be a function of the hand object. Remember, the hand object contains the function for drawing cards. So we're going to say the cards within the hand are going to be updated by taking the current cards, and then we're going to combine it with drawing the shoe, 1 card from the shoe. So I'm giving the shoe object, taking the shoe hand $shoe. Remember, this is a function, so we're calling the function for drawing the shoe, and when it's done, we return the hand here. Okay, so I'm going to just call hit on on the function here. Okay, so currently my cards is a 10 and an 8. You would not do this in real life, but if we were to hit this, we get a 10, 8, 10, and now my hand is worth 0. Okay. What happens if I hit my cards again? What would it show? Let's just see. Okay, it shows 10, 8, 7. Okay, what happened to the 10 that was over that I drew here? So remember, we're dealing with these are not reference class objects. Okay, so here when you take a function, you give it an input and it gives an output, and unless you capture that output just gets printed and then it disappears, right? If we want to keep track of all of these things that I've drawn, I can't. I have to update my hand this way, right? So hit my cards returns a hand, but if I want to store this, I have to do. I have to call this my cards. Is going to be. I have to capture that, okay? And now I can say. This is my cards, it's this, and now if I hit my cards, now we can see what happens, and then I would have to, do this, okay? So this is the difference. When you have reference class objects, you can do things like hit my cards, and it updates the object itself, okay? Because in reference class objects, the update takes place right there, right? You're using they're mutable, and so we're updating things that way. But over here, if we want to capture our output, we've got to update our hands accordingly. Okay, because if I just do that, it prints out our output, but this output is lost, right? Much in the same way, if I do 4 times 5. It prints out 20, but I didn't actually capture this output anywhere. So this 20 just shows up on my screen and gets lost. Okay, here's a function for standing. Stand just returns the hand, right? It's just, you take the hand and you're not going to do anything to it. We're just going to stand. That's the hand. Okay. In blackjack, you can do something called double down. Okay. What double down normally, the way double down works is that you're dealt 2 cards, right? You dealt maybe a 3 and an 8. Okay. Your 2 cards add up to 11, and you're going to say, okay, you know what? I feel pretty lucky. I'm going to draw 1 more card, and then I'm going to stop and use that. Okay. And so that's called doubling down, and I don't know whether the idiom double down came out first, or if it came from blackjack. Okay, when you know. All right. Anyway, so when you double down, you take 1 more card. You're actually doubling your bet. You're gonna, if you bet $10 now, you have to add another $10, and then you take 1 more card, and then you're done. Okay, and you're hoping you draw 10 and you get 21 or something like that. Okay, so here double down. What we do is we take. Again, we're passing it the entire hand object. We're going to take the bet in the hand object and update that to say it's going to be 2 times the bet. We're going to hit our hand and update our hand accordingly, and then we're going to stand, okay, which returns the hand itself. So this is double down. So I can take my cards, which are currently an 8. If I double down, I got a 4, and I end up with a 12. Okay, but you can see my bet has doubled now to 14. So that is doubling down. Okay, over here we've got 1 more function, and this is called splitting. And so in blackjack, if you get dealt 2 of the same card, you can oftentimes split them. Okay, now the rules depend from casino to casino, but generally. Getting dealt a 16 is like the worst thing, because the way the dealer works is that the dealer keeps drawing until they get 17 or higher. So at 16, it's like you don't know whether to hit or not, because if you hit, you might go over 21 and lose. or if you stand, you might lose to the dealer just because the dealer does better than you. So you don't know. So if you get dealt 2 8s, a lot of times you can split them, and you now are playing 2 simultaneous hands. Okay? And so what you do is you take your 2 8s, you split them, you have one hand, the dealer will deal another card over here, and then they'll deal another card on the other hand, and then you'll have, maybe here you have an 8-3, and over here you have an 8-10, or something like that, okay? But to split it, you have to put a bet, another one. So if you started off with $10 over here, you can say, I want to split, but you got to pay another $10 to have this other hand in play, okay? So now you got a total of 2 hands, each with the same bet, okay? And so we can see how this works. So when we split it, we're taking our hand, and we're going to return back a list of 2 hands. Okay, the 2 hands that we get will be a new hand. Again, the new hand, we require that we give it the shoe object, or the shoe function, showing how to draw new cards. And then what we do is we are going to take the first card in our currently existing hand and append one more card drawn from the shoe. And then we're going to take our current bet and say that's part of our hand. Then the other hand will be the second card from our currently existing hand, plus one more card drawn from the shoe, which we also pass it, and then our current bet. So the split pair will do that, okay? And so right now we don't have a check to make sure that we're even allowed to do that. If we take a look at my cards, they are not a pair. It's 5-3, and so the casino would not let you do the split, but we're just going to try out our split pair function here. We're going to do split pair on my cards, and we see we get back 2 hands. We see that we have the 5 over here, and we drew a 9, and we have 14. We took the 3 from over here, we put it here, we drew a 5, and now we have an 8. Okay, and so now I have 2 hands, each with a bet of 7, and that's how you split a pair. Okay, and obviously we want to capture this output here. Okay, so splitting a pair, we have it run that way, and so we can try this out. We're going to run out of time here before we got into the really interesting stuff. So here we're going to draw a new hand for the dealer, new hand for the player. Okay, the dealer, when you play blackjack, the dealer only shows one of their cards, so we can just say the dealer is currently showing a 5. We currently have 15. We have 6 and 9. We have 15. So maybe we will hit. Okay, and again, because these are functions with inputs and outputs, we have to capture that output. So we're going to we'll hit, and we'll see what is our hand. Okay, so we drew an ace, and we're at 16. Okay, so in this case, we'll take a look at our dealer. The dealer currently has 10. The dealer will hit because they have to hit until they get 17 or higher. The dealer drew a 10. They get 20. Okay, and so now we want to see, did we win or did we lose? We know we lost, but we'll run it through the winnings function. The winnings function will do a hand value of the dealer's cards and hand value of the player's cards, and it says we lost, -1. Okay. Okay, and here's a function for how the dealer picks their cards. Okay, and so the dealer will draw 2 cards from the shoe. Okay, and then the dealer just has to keep hitting until they are at 17, until they're over 17, or until they bust. Okay, so while the so we have a while loop that just says if the hand value is less than 17 and you haven't bust, hand value is still over 0. If you haven't bust, keep drawing cards. Okay, cards will be just keep drawing from the shoe. So this is how the dealer is going to draw their cards. So we can just do dealer underscore cards taken from the shoe, and so this is so the dealer will draw 10 3 10. They bust. Okay, so here this is just what the dealer's getting. So here 2 7 10. The dealer ends at 19. Here 2 4 8 10. the dealer will bust in that case. Over here, the dealer busts again. So sometimes that happens. And okay, we'll stop here. You know, if you have the time, I encourage you to read through the PDF that I have posted regarding simulating blackjack. It's a good article to get through. Okay, we'll see you guys on